Hello, this is part two of advanced trigonometric integration. So we're going to just continue off uh, from example 6. So we have the integral of secant fourth x times tan 6x dx. So what do we have? We have a secant and a tangent. And what do we know about their degrees? Yeah, so they're both, we have a secant and tangent. And what do we know about the degrees? They're both even. So if we're both even, we're going to use even secant or the B set. So if we're gonna use that, we're gonna do even secant. So we're gonna do U sub. Okay, so you're gonna use U equals tan of x, and du is secant square x dx. And let's see, we have secant fourth of x. So we're going to rewrite secant fourth of x as secant square of x times secant square of x. And then, so we're going to rewrite the problem as secant square of x times secant square of x. And then you're going to replace u with tan of x. And since we set u is tan of x, my du, the derivative du is secant square of x dx. Okay, so we're going to rewrite this problem as secant. We have a secant So I'm going to leave this secant square alone. And then this tan of x, we said that's u to the 6. And then we had an extra secant x dx right here. Now that becomes du. And what else do we know? We said that secant square of x. We also know that secant square of x is the same thing as tan square of x plus 1. So you're going to replace this with tan square of x plus 1 times it by u to the 6 du. What else could we do? Well, tan square of x is the same thing as tan of x to the second power plus 1 times it by u6 du. And what else do we know? We know that u is tan of x. So this is going to be u squared plus 1 times u6 du. Boil this out. U squared times u6 is u8. And then 1 times u6 is u7. I mean, 1 times u6 is u6, not u7. And then we have the du. Okay, so what to do next? What's the integral of u to the 8? It is 1/9 u to the 9th plus what's the integral of u to the sixth? It is 1/7 u to the seventh plus c. And then if you recall, our u was tan of x. So my final answer is going to be 1/9 tan of 9 of x plus 1 place x with tan of 7x. Let's see. Okay. Let's move on to example 7. We have the integral of secant x times tan square of x d of x. So we have a secant x and a tan of x, and this is a power of 1. This is a power 2, so we neither have it. So what do we have? We neither have, so we have an odd and an even. So we neither, we neither an odd tangent or even secant. So what happens? So if we had an odd tangent or an even secant, and we have so what we have is an even tangent. And an odd secant. Okay, what do we do? We don't have Otis, right? We don't have Otis, or we can't use even secant. What we'll do is use one of our identities. Let's start with tan square of x. What can we reduce tan square of x to? Secant square of x minus 1. So that's what I'm going to do. I can't use Otis, and I cannot use ESUT. Right? So I'm just going to have to use some identity and simplify it. And the identity I'll use is tan square of x. So I'm going to rewrite this as secant of x times tan square of x, which is secant square of x minus 1 dx. And then if I FOIL this out, this is going to be secant cubed of x minus secant of x d of x. So how would I take the integral? There's a minus right in the middle, so maybe I can separate into two separate integrals. So I could say integral of secant cube of x d of x minus the integral of secant of x d of x, right? And what else could I do? So on this one, secant cube of x, I can rewrite that as secant square of x times secant of x d of x minus the integral of secant of x d of x. How do we do this? Well, this one's easy. The integral of secant of x is, what is the integral of secant of x? Integral of secant of x. Get it? So the integral of secant of x is Oh, ln. So the integral of this is the ln of the absolute value of secant of x plus tan of x. How can I not forget that? Okay, that's easy, but this one, this is not. How do you think you're going to do that one? How am I going to take the integral of secant square of x times secant of x? You must do integration by parts. So what's your u and what's your dv? So my u is secant of x, and my dv is the leftover, which is secant square of x of d of x. Okay. And then if that's my u, that's my dv, what is my du? My du is secant of x times tan of x of d of x. And my v is the integral of secant square of x d of x, right? So what's the integral of secant square of x? It is positive tan of x. So if you recall, the integration by parts is uv minus the integration of v du. And we already know our u and our v, so my u is secant of x times v, which is tan of x, minus the integral of v du. So v is tan of x, and du is what's this whole thing. So it's secant of x times tan of x d of x, right? Okay, so we kind of have a mess. And then don't forget the very end. So this one right here is minus okay, what to do next is what can I do here? Well, I guess we can clean this up. So this part right here is just secant of x times tan of x minus over here. We have a tan of x and a tan of x, which is tan square of x. And then you have a secant of x, d of x, minus this thing. Uh, so this was our original integral, right? If you go back, secant of x, tan of x, uh, yeah, that was one of our original integral. So we can replace this with original integral. And then we have this secant, then we have this, but I'm gonna say, I'm gonna put the secant first. So if we go back to, so our original problem was the integral secant of x times tan square of x d of x, and then that's going to equal to secant of x times tan of x minus the integral of tan squared of x secant of x dx minus this whole thing. Okay. Now what I would do is maybe move this negative tan squared of x secant x dx to the left by adding both sides. So this, you have this, whoops, you have this and this. Once you add that, they're practically the same thing. So you can replace that with 2 of that. So 2 integral of secant of x tan squared of x dx. And then you're left with, on the right side, you're left with the secant of x. You're left with this, right? Secant of x times tan of x. And then minus this, right? Minus, it was originally minus secant of x, but we know that that's the same thing as minus ln of the value secant of x tan of x. What do I do next is maybe we should I think we should do that at the very end. So let's just replace that with minus what we originally had with secant of x. So what am I going to do? I think this will be the same. So I'm going to rewrite this as this minus. Now right here, I don't want to take the integral secant of x, but maybe, yeah, this one's what I would do is, I'm going to multiply secant of x by secant of x plus tan of x over itself, right? So I'm going to multiply this by secant of x plus tan of x over secant of x plus tan of x, right? That's what I'm going to do. And this doesn't really change the problem because what's secant of x plus tan of x divided by secant of x plus tan of x? It's just 1, and what's 1 times secant of x? Secant of x, right? Don't forget the dx. Okay. So what I'm going to do next is for this one right here, for this part, I'm going to do some kind of u substitution. And I'm going to use u equals secant of x plus tan of x. And then my du is secant square of x plus secant of x times tan of x dx, right? So my u is secant of x plus tan of x, and my du is secant square of x plus secant x times tan of x dx. Okay, so let's clean this up. So this one stays the same. Minus over here, hold on. So this is going to be if our u is secant x, if our u is secant of x plus tan of x, so this is 1 over u, and then the derivative of that is secant square x, secant square of x plus secant of x tan of x. So if you multiplied this out, that would be secant square of, that would be a secant square of x. So that just becomes du. Okay, and we can go from on. So what's the integral of 1 over u? It's ln of u. So the integral of secant of x times tan square of x. Okay, and then I'm going to replace this u with secant of x plus tan of x. Okay, and then what would I do next is I'll probably get rid of this 2. To get rid of 2, you multiply both sides by the reciprocal of 2, so we're going to multiply it by 1/2. So 1/2 times 2, it disappears, so you're just left with the integral of secant of x. And then when you multiply the right side by 1/2, this is going to be 1/2 secant of x, tan of x, minus, so you're multiplying both sides by 1/2, 1/2 ln of secant of x. Okay, and that is your final answer. Okay, let's do example 8. Oh, okay. Yeah, I think that's for that section. That's fine. We're done with that one. Let's move on to what happens if integrals involving sine and cosine. So, for example, if you had like sine integral of sine of 3x, cosine of 2x, 3x and 2x are two different values. So you're gonna have to use this rule. So you just got to decide which one is the most appropriate. So sine of m, so first one is sine of mx times sine of nx is equal to 1/2 of cosine m minus nx minus cosine n plus nx, where m is greater than n. Rule 2, sine of mx times cosine of nx is equal to 1/2 sine of m minus nx plus sine of n plus nx, where m is greater than n. Rule 3, cosine of mx times cosine of nx is 1/2 cosine of m minus nx plus cosine of n plus nx, where m is greater than n. So let's do an example. Evaluate by rewriting the integral using product sum identities. So we have the integral of sin of 3 of x times cosine of 2x dx. So they're two different values. And I think we're going to use rule, we have a sine and a cosine. So I think we'll use rule 2. So let's see. Rule 2 is going to be expressed as 1/2 parentheses sin of m minus n of x plus sin of n plus n of x, where m is greater than n. And I believe our m is going to be 3, and my n is going to be 2. So it's going to be expressed as the integral of 1/2 of sin m minus n, so it's 3 minus 2 x plus sin of m plus n, so that's 3 plus 2 x dx. So 3 minus 2 is 1x plus sin of 5x d of x. So how can we do this? So if you want to, you can put that 1/2 in front. So that's going to be in the integral 1/2 of sine of x plus sine of 5x dx, right? So I think we're fine. We can take the integral of each term, right? So we took out 1/2. So what's the integral of sine of x? It's negative cosine of x. What's the integral of sine of 5x? It's negative cosine of 5x divided by the derivative of 5x, which is 5. And then don't forget the plus c. Your final answer is going to be negative 1/2 cosine of x minus 1/10 cosine 5x. Let's see. Let's do another one. So example 10, we have sine theta times negative 3 theta d theta. What we know is that you can replace, we know that sine of negative theta is the same thing as negative sine theta. So what we could do is rewrite the problem as sine theta, and then replace this negative 3 theta as negative sine 3 theta d theta. And then you have a minus here, so you can put that in front. And what else could we do? What if maybe I should put the 3 theta in front? Maybe that would help because that's larger. So you could say sin of 3 theta times sine of theta d theta. So now I know that our m, so we're going to use rule. We have a sin and a sin. So maybe the first one, right? So you recall, is this the one? Okay. So my m is 3 and my n is 1. So now it's going to be 1/2 of cosine of 3 minus 1 theta minus cosine of 3 plus 1 theta theta. Okay, so 1/2 is a constant, so you can put that in front, and then you have a negative. So it's going to be cosine of 2 theta minus cosine 4 theta of d theta, right? Now we could just take the integral of each term. So what's the integral of cosine 2 theta? It is sin of 2 theta divided by the derivative of 2 theta, which is 2. And what's the integral of cosine? It's negative sin of 4 theta divided by the derivative of 4 theta, which is 4. And then times this by negative 1/2 plus c. My final answer is negative 1 sin 2 theta 4, and then distribute this negative 1/2. So that's the negative times the negative is positive 1/8 of sin of 4 theta plus d. Okay, that's my final answer. Let's move on to the last one. Okay, last one, question 11. So we have the integral cosine of 5t cosine of 5t times cosine of 5t. And we know that if cosine of negative theta is the same thing as cosine theta. So we're going to rewrite our problem as the cosine of 5t times cosine of 4t dt. And we know that m is 5 and n is 4. So we can rewrite this problem as the integral of 1/2 of cosine of m minus n, so that's 5 minus 4 t plus cosine of m plus n, so that's 5 plus 4 of t dt. And then 1/2 is a constant, so that's going to be cosine of 1t plus cosine of 9t dt. The integral of cosine is sin of t. The integral of cosine 9t is sin of 9t divided by the derivative of 9t, which is 9, and then we took out a 1/2. So this is going to be 1/2 sin of t plus 1 1/8. So we gotta FOIL this 1/2, so this would be 1/18 sin of 19. Let's see. Okay. So yeah, that's the last example, and then we'll stop right here.